Hi guys, so let's discuss about the IPv4 addressing, subnetting and routing. Introduction to IPv4. It is the fourth version of the Internet Protocol and is the most widely used protocol for identifying devices on a network. It provides a unique address to every device connected to the Internet so that data can be sent accurately from one device to another. When it comes to addressing, it is the method of assigning IP addresses to devices in a network so they can communicate. It uses 32 bits divided into 4 octets. Basically, it is written in a dotted decimal format, that is 192.168.1.10. Now let's discuss how we did this. When there is a router, so let's take a router, that is ISR 4331, where we'll be disconnecting here. Then we have two switches, 2960 here and switch 1. Then we have PC. We'll be connecting 4 PCs to the two switches, and we'll have to configure this by giving IPv4 address, that is 192.168.0.1, and a subnet mask and a ring limit, that is 10. Then we'll have to on this port status. Then we'll have to connect two switches to the routers, and we'll have to connect other two PCs to one switches. For PC, we'll have to configure it, that is we'll have to give it static, then it has to be IPv4 192.168.0.2. we'll have to give subnet mask, default gateway. For each PC you will have to configure it. The same thing continues in the PC1 as well, and PC2 and PC3. Now let's show the packets. From PC0 to PC1 it's successful, and from PC2 to PC3, from PC0 to router, from PC1 to router, from PC2 to router, and PC3 to router. Right, everything is successful. So let's show the simulation and start it. Here, once the packet is received, you will receive an acknowledgement pack. That's when the status is successful. You can see here the status for all the 4, it's successful, that is source PC0 to destination PC1, PC2 to PC3, PC0 to router, PC1 to router. Now let's talk about routing. Routing is the process of forwarding data from one network to another network using a device called a router. It enables devices in different networks or subnets to communicate with each other. Think of routing as a post office system. You write an address on a letter, so the post office decides the best path to deliver it. Similarly, a router chooses the best path for data packets. Now let's consider a simple example. Now if I want to deliver from PC0 to PC2, I'll have to connect the two routers, or else it won't be successful, it will be failed. Basically we have two types of routing, that is static routing and dynamic routings. So static routes are manually configured, and in dynamic routing, routes learned automatically using protocols. We'll be doing static. Here we can see that in configuration we will give an IP address and everything, and for the PC0 we'll have to configure each PCs. So let's see that what types of components we have used. In routers we have used 1841 router 0 and 1841 router 1 and 2 types of switches and 4 PCs. Now let's see if it is successful or not. From PC0 to PC1, let's go to the real time. PC0 to PC1, it's successful, and from PC0 to router 0, PC1 to router 0, PC2 to PC3, PC2 to router 1, and from PC0 to PC2. Now let's start the simulation. While the simulation is happening, let's discuss about the color code. That here the green symbol, that is the triangle symbol, symbolize that addressing is on. Basically the Cisco packet tracer, the link or the port color symbols communicate the different states. Here we have green color. This means the physical link is up. If it is red instead of green, it means the physical link is down. If orange, usually the device or port is in a blocking state. Now we have green, so the packets are being delivered and will be receiving an acknowledgement. That's when the status is successful. Now every thing that the source and destination is successful. So let's stop the simulation. This is how the IPv4 addressing and routing works. Thank you for watching.